Okay, Rachel. Now we're going to deal with section 10.4 of the book. Consider that you have a circle, and let's take 2 points on that circle, label them H and F. As you know already, arc HF is an arc of a circle, and the normal way of writing that, arc HF, is usually written as HF with a little arc on top. Now, what do we mean by measure of arc HM? When we say measure of arc HM, what do we mean by that? And that's usually written by your little m and then HF with the little arc. The measure of arc HM has to do with the central angle that is associated with arc HM. Listen to that carefully. The measure of arc HM has to do, of an arc HF, has to do with the central angle that is associated with that arc or those 2 points. Let's look at it in the figure. In the figure, so back to the center of the circle. The center of the circle, you need to draw the 2 radii from the 2 points at the end of that arc. And the angle here formed by those 2 radii is the measure of that angle. The measure of that arc. You should already know that from earlier sections of this chapter, section 10.1, 10.1, 10.2, and 10.3. I'm just going over that because it's very critical that you understand that. So anytime you're talking about the measure of an arc, you come back to the center. It's dealing with the center. Okay? Now, associated with these 2 points, however, is also what they are calling the inscribed angle. You see, here I've written the same 2 points on the arc, on the circle, the same 2 points that define the arc, which are 2 points on the circle, can also be associated with an infinite number of inscribed angles. What do I mean by an infinite number? Let's look at all a few inscribed angles that we can associate with H and F. Now, remember now, the measure of arc comes back to the center, but the inscribed angles have to go back to the perimeter of the circle. What do I mean by that? Let's use green, the green color, to show a few inscribed angles. So, for example, there is an inscribed angle associated with arc HF. So arc HF has this angle as an inscribed angle. But we can draw so many of them. This arc HF we can draw an infinite number of inscribed angles. How? Here's another one. Here's another one. Here's another one. All that matters for you to have an inscribed angle, all that matters is that you begin a line at one of the 2 points, you draw it and touch the circle, and then you draw from where you touch the circle, you draw back to the other point. So you can begin to see that you can draw so many different inscribed angles. So for any arc HF, you can draw uncountable number of inscribed angles. But there's only one central angle that you can draw. Okay, the one in red. because that one comes to the center and it's unique. So H coming to center, going to F. Whereas all the other ones, H goes to the circle, comes to F. H goes somewhere else on the circle, comes to F. H goes, okay? So I hope you get that, because that's really the key thing here. The theorem, I believe that's theorem 10.7, basically then says each of these inscribed angles, of course, each one is equal to half of the measure of the arc. Do you get me? An inscribed angle associated with an arc is equal to half of the measure of the arc. Okay? I hope you get that.